You're welcome to yet another video. This time around, we want to continue with the nature of curves. So this video will take care of the part 2 of the part 1 part of the nature of curves. This time around, we want to look at some curves starting with the absolute value curve. So, for example, having the absolute value of x, we have a curve like this. So note it, this is the absolute value curve. Now this means that whether you're going to have a negative x value, the corresponding y value will still be the same. So this left hand side occupies the negative range or negative domain of the x values, which maps to the y domain, which is actually a positive value, which is actually the range actually. So whether or not it's going to be a negative domain of x or a positive domain of x, it was still having the same y, positive y value. This implies that actually this curve is not a function. Yes, this curve is not a function. So this curve, whenever you see it like this, note that is an absolute value curve. Let's quickly go on to other type of curves. Now in the case where we have log x, let's see what it produces. So log x produces a certain parabola like this form. So just note how it looks like. Any curve in this form represents a logarithmic curve. Good. Right. Also, let's look at this kind of curve, 1 on x. 1 on x curve produces a form of curve which are twin-like. Actually, there's some discontinuity in this kind of curve because it is not continuous. There is one part here, another part here. Good. So if that's the case, then let's look at the curve x. Curve for the value x, how it's going to look like. The curve having the value of x is going to pass through right in through the middle. That is y is equal to x. That's the curve we are talking about, and it has a gradient of 1, as you can see. So whatever be the value of x is going to have the same or a similar value for y, and this is how, or this is the kind of curve that it produces. Good. Now let's also try to look at this kind of curve where we have the root curve or the root of x, square root of x preferably. Now that's the yellow curve here. Note that it looks like this form. Yes, so any curve of this form is actually the root or the square root curve. Let's also jump quickly into the trig curve. So the sine of x, note the difference between the sine curve and then the trig curve. Sorry, the sine curve, the cos curve, and the tan curve. Now among the sine and the curve, there's particularly one particular difference. So note now the color for the sine, and let's see what it's going to produce. So the sine curve produces this kind of alternating curve which passes through the center or the origin. Now the same way, let's look at the cos curve. The cos curve has a peculiar feature but does not pass through the center. Let's take a look. Good. So the cos curve does not pass through the center as in the case of the sine curve. But amongst all, remember the relationship between tan and cos is just a quotient relationship. So let's look at the quotient of sine and cos, what it produces actually. So tan x gives us a new form of curve, and look at it. Good. So this pink curve, series of pink curve, let me try to, yes, series of pink curve that we have here is the tan curve. Actually, they are beautiful. And in our subsequent videos, we are going to do more graphical analysis to what we have here. Cases where you are asked to find the the minimum, the maximum, um, the maximum value, the minimum value, the cases where you are asked to find the critical points, cases where you are asked to find um, the point of inflection and others. So stay tuned. Don't forget to subscribe, and there is more in stock. Thank you for watching, and bye for now.